Next one up, we have a very special guest, Jason Crawford, who's joining us today. So Jason has kicked off this project, the Roots of Project, the Roots of Progress project. Now it's an actual institute. You guys have a fantastic fellowship that's absolutely amazing, and I really encourage those of you who are interested in writing about progress to check that out, or reading. The fellows are doing fantastic research. And we hosted a really, really great event this year. You guys instigated the most, I think it was really one of my absolute favorite events of this year. It was the Progress Conference, and you're already scheming on the next year and what it could look like. It was really, really great. I encourage all of you guys to go and to sign up. All right, well, without further ado, there's a lot more I could say to that, but I think you can say it much better than me. But if there's one kind of like figurehead of this progress movement here in the Bay, then it's definitely you. So I'm excited to hear what you have to share with us.
Thank you so much for that very warm introduction. And I mean, I will just return the compliment to this event. You know, this Vision Weekend is one of the things that that's like the only other thing that I go to like every year and tell other people they should go to. So great. So we're here to talk about existential hope. We're hoping for a good future for humanity. There are different ways that we could hope for that, different kinds of things that we could hope for. One, we could hope for smooth sailing. We could hope that the future doesn't actually contain that many problems, or that building the glorious techno-abundant future that we're all hoping for is maybe kind of easy. You know, so that's hoping for no problems. This is a type of optimism. It's a kind of descriptive optimism because, you know, it's an optimism that says, hey, we're on the right track and everything's going to be great. The other thing you could do is you could expect to have major problems, but hope for solutions, right? So you could be maybe even pessimistic about the dragons that we will face in building the future, but then optimistic that, you know, the night will come along to fight the dragon. And so this is a more prescriptive optimism, right? It doesn't say that things will be great, but it tells us to step up to the challenge. So my optimism, my form of existential hope is definitely the second form, right? I don't at all expect that the path will be easy or that the sailing will be smooth, but I believe in our ability to solve problems. In fact, I believe that humans at a deep level are problem-solving animals, that solving problems is fundamental to our nature. Now, part of why I believe this, of course, is our track record. We have an excellent track record as humanity of solving some of the most important problems, solving them extremely well, and across a very wide variety of domains. So this is not a fluke. We've solved problems of how to feed ourselves, how to construct shelter, how to get around the planet, how to prevent disease, and many, many more. And, you know, the solutions were not obvious. They seemed, you know, the problems seemed insurmountable. In fact, the solutions often seemed very far off right up until basically when they were discovered. So in 1901, Wilbur Wright said to Orville that men would not fly for 50 years. He was only off by a factor of 25. Okay, but that's just past, you know, performance, right? Past performance does not guarantee future results. So will this pattern continue? Will we continue to solve problems, or was the past a fluke? Is our luck going to run out sometime soon? Well, I think there are deep philosophical reasons to believe that we will continue to solve problems. There are two facts that give me this confidence. One is a fact about the universe, and the other is a fact about us or about the nature of intelligence. So the fact about the universe that matters is that the space of possibilities within the universe is vast. In fact, it is combinatorially vast because so many of the possibilities come from recombining you know, elements in sequences or in combination. So this is true in the world of atoms, for instance. The number of molecules that can be made out of, you know, even a small number of atoms is astronomical and just grows exponentially with the number of atoms. The number of DNA sequences we can have with, you know, at a certain length, or the number of you know, proteins that can be made out of a certain length of amino acid sequences, all of these things grow exponentially in combinatorial fashion. It's true in the world of atoms. It is also true in the world of bits. So the number of programs that we can write in a given length, or the number of neural networks that we can train with a number of different parameters. It's even true in the human language that makes up law and institutions and morality. So my existential hope extends not only to problems that have technological solutions, but also to problems that have social solutions. Now, of course, there's one problem with a combinatorial solution space, and that that grows exponentially, and that's that if you take a brute force search approach, it takes exponentially long to search and becomes intractable. There are two, fortunately, saving graces of the solution space that allow us to overcome this sort of exponential search problem. So one is that in a high-dimensional space, many of the viable solutions are in fact adjacent to each other, and so you can get pretty far just by variation and selection. This is, of course, how evolution does it. So you can just kind of do this hill climbing thing where you go through adjacent solutions, and that gets you pretty far. Problem is it takes like 1 billion years. We want to move a little bit faster than that. So the second saving grace, the thing that we can exploit, is that the possibility space has structure. It's not random, and the structure can be understood and modeled, right? And so this is fundamentally what intelligence lets us do. Intelligence lets us model reality and model the solution space. Sometimes the models are implicit, and we call them intuition. Sometimes the models are explicit, and we call them theory. And of course, these things work in concert. But intelligence lets us essentially efficiently navigate an exponentially large solution space to find optimal points within it. Now, this is, I think, clearly true of human intelligence if you just look at the human history, but I think we are also starting to see it is also true of machine intelligence. So just one very recent example, some researchers at the Arc Institute trained a large language model on DNA. And then they asked it to spit out like a megabase of DNA. And then they sort of looked at this to see, like, is this even a plausible genomic architecture, right? Now, nobody believed that this is like a real viable microorganism. It's almost certainly not. But if you look at it from various metrics like coding density or sort of how the genes are arranged, it's like very clearly different from a random sequence. They were even able to identify sort of a bunch of genes in here that had for proteins with recognizable functions. So just by training a language model on DNA, an autoregressive model, you end up with something that understands something about kind of the structure of the genome and can generate something that is very far from random. So in essence, I believe that problems are real and that we will face massive problems in building the glorious future. But the solutions exist somewhere out there in the vast combinatorial possibility space of reality, and we can find them through the power of intelligence. So that's my existential hope, not the blind optimism of hoping for no problems, but an optimism that is contingent on human ingenuity and intelligence and courage. Thank you. For more like this, check out the Techno-Humanist Manifesto, which you can find at technohumanist.org. Thank you.
Thanks.